Welcome to the Energy Central Power Perspectives podcast. This is the show that brings leading minds from the energy industry to discuss the challenges and trends that are transforming and modernizing our energy system. And a quick thank you to West Monroe, our sponsor of today's show. Now, let's talk energy. I'm Jason Price, Energy Central podcast host and director with West Monroe, coming to you from New York City. And with me, as always, from Orlando, Florida, is Energy Central producer and community manager, Matt Chester. Matt, I'm excited that today's episode is bringing to us the leading voice championing a new technology and approach for the world of utility substations. I won't call on you to explain that innovation, as that's best left for our guest, but can you set the stage for us why substation modernization and security may be top of mind for utilities today?
Of course. Thanks for that, Jason. For many years, the equipment like substations, transformers, and just the standard grid equipment has served as really the bone of the power sector, a key cog in the process of sending centrally generated power to where consumers need it. In more recent years, though, we all know the types of transformations that have been at the center of the utility industry. More distributed assets, changing where and when power is generated, a strong pull towards more renewable energy that just happens to be more intermittent in nature, a strong push towards and a general grid modernization of all equipment across the system. All of these changes bring with them some new and in focus areas of concern, but we've also seen some negative trends. The lead time for utilities to get new equipment and infrastructure has shifted from weeks to, in some cases, years, and rising threats, both physical and cyber, are constantly presenting themselves from bad actors. So with that transformation in opportunity comes an evolution in modernization and security needs. And those requirements really set the stage for our conversation with today's guest.
Yes, appreciate that, Matt. It is indeed a critical juncture for this area of utilities. And so the conversation we're set to have is no doubt one that power company leaders won't want to miss. And we're lucky to have the top voice in this area joining us today in John Bettler, Power and Protection Engineer at ComEd. For today's conversation, we're focused on how John is leading ComEd's Digital Smart Substation program, which utilizes the IEC 61850 GOOSE messaging for its protection. Having led a team that's designed and installed 7 substations and a lab for this technology and is currently installing the first brownfield 61850 site, we're truly at the cutting edge today. And I know this is the type of episode where we'll simply want to maximize how much airspace we give to our guest to explain the intricacies. And so let's delay no further in bringing him in. John Bettler, welcome to the Energy Central Power Perspectives podcast.
Hey guys, thanks for having me as a guest. I'm super excited about this. I've been in the power business for a long time. This summer will be my 33rd year, actually here at ComEd. And yeah, a little background about me. I do have a master's degree in electrical engineering from IIT here in Chicago and an undergrad at Iowa State. And my focus throughout most of my career has been within substations and controlling substations specifically and protection for like when events happen, like lightning hits a transmission line, what happens. So my team has been working on that. And I'm actually coming from our Digital Smart Substation, our DSS lab today. So thanks for having me.
Awesome. And we're thrilled to have you here. So, John, let's dive right in. Start at the beginning. You've been making the rounds at conferences and in publications talking about the need for digital smart substations. For those of us who aren't as boots on the ground as you, what are digital smart stations and how are they a departure from the status quo?
Yeah, great question. Thanks. Yeah, a business or a digital smart substation has many aspects to it. One of which is IEC 61850, which is a way of communicating to devices, and it can move a lot of your infrastructure from copper wires to fiber wires. That's a big part of it. Another big part of it is creating smart HMIs, which are human machine interfaces. So when you're at a substation, what sort of intelligence are you getting there for the field forces, your operators, field engineers, field technicians? Do they have the ability to dive in and take a look at what's happening? And are you providing the right detail back? Doesn't necessarily need to go back to your central control center where those are more people who are operating the whole grid. But when you do walk into a substation and you're trying to troubleshoot or figure out what's going on, it's really important to have that. Another aspect would be to have good monitoring systems in there. Like, are you actively monitoring your transformers or your circuit breakers? And when I say circuit breakers, like, are you looking at your open times, your close times? What sort of, like on a transformer, are you taking a look at your oil and doing online monitoring? And when I say online monitoring, it's almost like getting a Fitbit for your transformer. Do you have that in place? And I would say at a digital smart substation, that would be a requirement. Creating other aspects to this would be, how do you get this data once you have all this data coming in and utilize it? Can you do fault locating? Can you do settings compare? And meaning you have all these settings that you've issued to all your relays. Can you go back and compare those to a central database so you know what you've issued for record is what's being applied to the relay and is in the field on the relay? And lastly is, your SCADA and your network. You're going to have a SCADA system there that's getting all the data and tying it together. What type of network do you have? How did you install your fiber? Because fiber then becomes a critical aspect to the whole DSS. And sometimes I feel like it's something that people don't really want to talk about too much. So that's kind of a DSS nutshell. I guess the one aspect too, when I talk about the fiber and the network, is a DSS would be IP communications for all your relays. So one thing you'd be, your bread and butter substation either didn't have communication or just had contacts or it was serial, but in a new DSS, your IP, you're going to be using IP communication to all your relays. So you'll have them onto a network.
Fantastic. But let's do the following. Help us understand the significance of the IEC 61850. Give us a primer on the regulation and what it means for utility.
Yeah. So basically, IEC 61850, I'll use this and people might not agree 100%, but I kind of view it as a technology standard that relay manufacturers and equipment manufacturers are implementing. It's a way to communicate between devices. So there's a standard format that they have to follow. And what it does for the end user is you now have three main areas of focus. There's GOOSE messaging, sample values, and something called MMS. And now GOOSE messaging is this publisher-subscriber relationship that devices have to communicate digital data for the most part. It doesn't have to be digital, but we'll just talk about it from a digital data standpoint. So I'm sending trip. I publish that out, and you guys both subscribe to it. And so what happens is you now can utilize that information because we've created a virtual wire between me and you two guys on the network. So what's really great about it is it's one-to-many, and then there's 200 relays at a substation. I publish out trip, and it only goes to the 3 relays that need to talk to me, so we can kind of control it that way. Additionally, there's technologies in the network that you can do to help limit any flow. So that's the GOOSE again. And what happens with GOOSE, though, is speed is critical. So there's no check back. It's also not routable, meaning it can't go through a router. It's not going to go out to a wide area network. It has to be local in your substation, at least right now, because speed is so critical when you're doing tripping. It does create some challenges that are actually, once you come up with solutions like we did here at ComEd, make it easy for testing engineers and technicians to work around. But there's some challenges in that aspect to how do you test it and implement it, because it's a big change from what the field's used to seeing right now. The next thing would be sample values. So I'm a relay and I'm taking in currents and voltages into my relay. 66.4 volts nominal would be for voltage, and let's say 5 amps nominal for current. I'm taking this in. Since I'm a microprocessor relay, what I'm doing to this is I'm digitizing it. I'm taking those quantities, those analog quantities, turn them into some digital quantity so that my relay can then process it. Because otherwise, you can't just take 66 volts and apply it to a chip and blow it up. So you do that. Now, the currents and voltages then go down the line to you, Matt, and you're going to do the same thing. So the concept here would be, hey, why don't I just take my digitized voltage and current and then send it over to you? And then you don't have to do that. So it saves you effort. It saves a lot of copper, and it saves, and it could be a safety concern too, depending on how you look at it. So that's sample values. And MMS is basically a SCADA protocol. Most of the United States is probably using DMP3 is going to be probably most people's bread and butter SCADA protocol. The issue with DMP3 when you go to a 6850 substation is kind of like having a phone or, a dictionary from 1975. If I gave you a dictionary from 1975, you're like, yeah, this will help me write my term paper. but it's lacking in some regards because it won't have modern terms. Like it's not going to have laptop. It's not going to have cell phone in there because those weren't really things in 1975. DMP3 has terminology that's very useful, and most of our central control centers are still using it, so you're going to be using that to some extent, but you can't get, like, did I have a GOOSE fail alarm, and certain things like that are not available. It doesn't have that vocabulary. So you might want to consider using MMS as a hybrid, at least to your HMI, and that's kind of the approach that we're taking. Some people could send it all the way out to the door, back to their control center, but most control centers are set up for DMP3, so that's a little bit tougher sell, at least in the U.S. market. So that's kind of 6150 in 5 minutes or less.
That was very helpful. All right. So let's just take a step back let's say, out of the weeds for a moment. I started at the beginning that you've been really championing this digital substation movement, and you've been out there on different platforms sharing the message and promoting it. So what has the response been like? What is the feedback you've gotten during this process? And just share us your general thoughts around that experience so far.
Yeah, it's been favorable. Of course, I'm going to places where people are interested in trying to do 6150 and a digital smart substation. They're both of interest to that. I'm getting a lot of questions on how we are specifically doing it. Sometimes that will lead some challenges there because we are doing some things a little differently. I have come across folks, and one of our foundations for us, at least on our design, is simplicity. Because if you make technology too hard to swallow, too technical, it's not going to sell. And it's too big of a leap for the field, and people won't adopt it, I guess would be the thing. So we really focused on making it simple. And so that's one of the big things that I've been selling out there, saying, hey, when you're creating a DSS program, you have to do, in my opinion, 3 things. You have to kind of think through and plan out what you want to do with all your stakeholders. Then you design as simple as design as you can, and then you have to follow it up with training and demonstration. And those are the 3 things that we've been kind of getting out there. And I think when I sell it in that way and tell people that's what we're doing, they sort of become more open-minded to it. In fact, I just recently had one of our sister companies, BG&E, came out here to see our DSS lab, and they brought some of their field technicians with them. And I think they had skepticism when they got here, but when I showed them how you can do it and how simple it can be, I think it started to change. I'm not going to say it made a full conversion, but at least I whetted their appetite with, hey, this is something we could probably do. And it's not so far out, off the road that we can't drive on it, I guess would be the way I'm thinking about it.
Sure. John, can you say a bit more about the skepticism? Why would utility engineers looking at a modern way of running the business be skeptical of that?
Right. Well, so like when you're testing something. So right now, when you're testing at a substation that has everything wired, I can walk up and it'd be like going down to your circuit breaker box, and you shut off a circuit breaker box and you see the light go out and you know that that's out. And that's the same thing. What happens is in a traditional system where you have traditional tripping, you can just pull a test switch and you can provide isolation with that. That's not how you do it in 61850. 61850, when you're doing GOOSE messaging, you can't isolate that way. But they did provide, if you're going to edition 2, something called test mode. And test mode's really cool in the sense that, so let's go back to the example where I'm publishing to you two guys. So I'm publishing out trip. As soon as I publish out trip and you put me into test mode, if you guys aren't also in test mode, you don't know what the heck I'm saying. It makes no sense to you. You're not paying attention to you. So just you ignore it. Now I put Matt in test mode and then I publish out the trip and I'm in test mode also. Matt now understands what I'm saying and will respond accordingly. Jason, you still are not in test mode, so you ignore what's happening. So it's in this way that I can use this test mode feature to prove my signal from me goes to you, to Matt, and then I'll put Matt not in test mode and put you in test mode, and then I can prove it goes to you. And so that's a new shift. And I think it's confusing for people until they actually see it in play. We also used some, what I'll call little tricks to do that so that I can make a signal from my relay, go over to the other relay in this test mode. I built in a lot of human performance elimination or HP tools in there so I don't have a human performance event. Like I made it so that if I'm sending this test signal and I'm in test mode, I can't leave test mode until I put everything right again. Tricks like that, once I show people what we're doing, they're like, oh, this isn't so bad. And it's actually, you're less likely to make a mistake in one of our 6150 stations than you are in a more traditional one, because then you're really counting on people understanding, to put stuff back. and this will tell you this is fully monitored. That's one of the biggest things about it is, when something works or something doesn't work. And, it's like having a Nest thermostat. When it's working, tells you what's going on. There's a lot of fancy features you can utilize. If you want to save energy, you can do that. We're saving energy, but that's not why we're using it. We're using it to monitor our circuits and tell us when there's problems. And so I think when you couple the ability to do the testing, when people start seeing that and then they see, hey, this thing's fully monitored, I think those two things start to get even the doubting Thomases to maybe say, hey, maybe this isn't maybe this isn't as crazy as I thought it was.
Right. Yeah. If there's one thing that's very common in the utility industry is change management and the science behind change management. People are always going to be skeptical or doubters with new technologies, but if the change management is executed properly, then you'll see a lot more uptake and adoption. But it also comes down to the success, like it does what it's supposed to do, which I think you're describing. So can you talk a bit more about the success stories you've seen and use cases you've seen? And I understand that you've been, had a hand in installing some of these digital smart stations outside of just pilot mode. So what has been the outcome been like? Do you have any specific stories or examples you can share?
Yeah. So a couple of things where I felt like we had some great success. And again, this came into initially when you're getting all your stakeholders, because where I've seen people who have, I've talked to people where this has not gone well. They pretty much gave it to the smartest engineer on their team, and that engineer went and designed something super amazing, but super complicated and didn't really engage others. So the one rule I said is engaging others. So for instance, when we created our HMI, I got inputs from all the stakeholders. In fact, I went out and talked to an area operator and I said, here's what we're thinking about doing this. And, here's what this looks like. What do you think? And he's like, is this engineered? I go, well, we're engineering it, but I want your feedback. And they told me, it goes, this is the first time anybody had ever asked their opinion before it got designed. So I think to me, that was a real big success and kind of telling of how, you get into habits of designing stuff and you forget to leave out stakeholders. So I think that was an important aspect right there. The other thing that what happened was we were out testing and how we're using our 61850 where we have this test mode and we have built in like test trips and stuff. So I brought a bunch of people out when we first were doing one of our pilot stations and from our real-time analysis group, because I know that they're going to be eventually answering questions on this because they respond to all events. So I got them out there. I said, here's how we're going to do all the trip checks. And this was a station that was being built. It was, fine to go out there and do that. So I showed them, okay, here's how you send a trip from here to here, put this in test mode, and did all that. And then by the time they left, they were pretty comfortable and confident about how everything worked. And so there was a huge, these folks walked in not really knowing too much about this and walked out being able to do trip checks and explain to a reasonable amount of what was going on. So that to me was a success. On our 34 kV, because we're about to go and do our fourth and fifth 34 kV substation, we have that down as long as the topology, when I say topology, meaning our planning department creates a one-line diagram, which has, a certain number of feeders on a bus and where transformers get connected. As long as that doesn't really change to any great effect, our designs are done. And so now it's really going to come down to incorporating, the template settings and, doing name changes and then, being out there to support the field and training the new, if they're going into new areas, showing those people how those engineers and technicians how it works. But as far as that goes, it's been, super easy once we got through the growing pains. Now, the growing pains were, you got to make sure you're creating template settings that are standard. That's the biggest thing I'll say is standardization is key on any design. Because if you make it standard, the driver's seat is always on the right-hand side. It's always going to be easy for everybody to adopt. So that was one of the things that we did. So like logic that we used, even at 34, it was the same logic we used at 345. We're using at 12 kV. We tried to keep that as similar as possible. So those are kind of some of the successes that we've really had that I felt have been, really, telling on how we move forward. Or that I would tell to other people that this is, make sure you do this and you will also have success, if that makes sense.
Yeah, it does. No doubt. You have to engage stakeholders. You need to collaborate, simplifying the process, standardizations. Those are all key to successful deployments. So it sounds like it's a slam dunk, and yet I'm sure there are barriers to, getting this out and rolling it out wide scale. So what is it? An issue of just general awareness, fear of something new? Is it a workforce talent development concern? Is it a cost issue or something else? Just what are your thoughts around that?
Yeah. So for us, we started with doing it at greenfield sites. So it's a lot easier to implement at a greenfield site. And it's a lot easier to implement just from a financial and an actually engineering standpoint. I think people keep asking for justification. One of the things that they come out as to how do you justify it? And again, if you go to a greenfield site, you needed to have protection there anyhow. So really your only real delta is the development costs. And again, from my perspective, your development costs start saving you money probably station 3 or 4. So if you're going to be making the same type of station, you're going to produce 10 of them in the next couple of years, then to me, I think that is the perfect candidate to look at trying to do this stuff.
John, if I can jump in, to clarify, when you say greenfield, you're talking about say a new geographic area that doesn't have a substation. The plan is to build a new one out. Is that what you mean by greenfield?
Yep, that's exactly correct. Thank you. Yeah, sorry if I'm using words that are terminology that folks aren't familiar with. It could be at an existing substation and you're just maybe you have outdoor gear and you want to go to indoor gear because it's more reliable. Or you need to expand a place and there's not enough room to expand it at transmission level. So you're going to go to GIS gear, which is gas insulated switch gear. So you're putting in everything new and you're cutting over to this new substation versus a brownfield. Like we did a brownfield and we took one bus out, we upgraded it, and the whole rest of the station stayed older electromechanical relays, and it was even on a different voltage level. And so that would be a brownfield. When again, brownfields are a lot more challenging in this aspect that you have to figure out how do you interface between your new 6150 substation and DSS substation and the existing substation. So I think if you're going to look at it and you're thinking about trying to do this, you need to focus initially on greenfields because then again, your costs can be somewhat, included in just the overall design of the substation. You have to be thinking about, reliability and how do you do, because you're going to be using fiber for the most part. So if you're not comfortable with fiber, you need to make sure you understand how that's going to be implemented. ComEd is very, used to using fiber, and we had already been doing stations with fiber. But now when we do it with the 6850 and we have the tripping going on, it becomes even the next level up from there. So that's one thing that I think you got to make sure folks address. The other is you got to come up and develop a training program and make sure that however you decided to do this, you need to then, once you do a pilot and you deem that pilot successful, then you have to be ready to, hey, let's roll this out, get to the next one. I feel like a lot of, places, they just spend too much time analyzing it. And by the time they never pull the trigger because they're never done analyzing stuff. So that's the one cautionary thing I think can happen. I don't care where you're working and what industry you are, but if you're not at least thinking that, hey, I really want to do this and you're passionate about trying to make it happen. And then once you do, get folks in there training and move on to the next project at that point in time. And you got to actually have senior leadership. At ComEd, we're very supported by our senior leadership, which makes it an awesome place to work as an electrical engineer. So.
Yeah, no doubt. I'm not sure if you're aware, but we've had the luxury of interviewing both Calvin Bettler as well as Gil Quinones when he was at NYPA, leading NYPA. So when it comes to leadership, you're world class, the leadership you have both at Exelon and at ComEd. So that makes complete sense. And speaking of leadership, you have your own leadership as in you in terms of leading the next generation of support to help continue driving this and evangelizing this technology. So you, as I understand, you work with a team of interns. You've been training them on this technology. Can you share some highlights of this program that you developed and why it's so important and what you've gotten out of it so far?
Yeah, that's great. Thanks for bringing that up. Yeah, so 2 of our interns, they go to NIU, Northern Illinois University here. And so we were talking, the one of them actually lives across the street from me. And I know his parents, I was the one who's kind of pulling him in to become, hey, why don't you think about going to power? He was a Navy electrician's mate on a ship and a destroyer for 5 years. And he came out and he started going back to school. I said, hey, what about power? So he started going that route. Then he got an internship with a testing company. And then he was doing an internship with us. And I met his other buddy who was a recovering auto mechanic. He's now going back to school for electrical engineering. And so I talked to them and said, hey, when you do your senior project, what about doing 6150? Right now, we are pretty vendor specific. So I said, it would be great to do the 6150 so you can do this GOOSE tripping and demonstrate it goes in between different devices. So we have Schweitzer, ABB, Siemens, and GE relays. And Siemens has been great, and Schweitzer have been great. Both those companies have really helped us get through stuff. And so I got them equipment, kind of set them up, put them in touch with the right vendors. And then they started building this like little mini substation. I would mentor them, like every once a week or so initially. And there's 2 other guys on their team from their class, and the 4 of them has been great. I was there over Christmas. They worked hard on this over Christmas break, and they got the GOOSE messaging working. And it was like, I thought they're going to have a party after they got the first 2 relays talking. And again, it's funny to think about because these guys don't, I work in an engineering department where we do that all the time. This is just something they're picking up, and it's been awesome to see. We just had a meeting last week, and they're going to start trying to do MMS to the relays. So we set up a call. And actually in a couple of weeks, I'm going to have a challenge. They have to present to their university, but I'm setting up like an internal expert challenge session, give them 1 hour to say, hey, why don't you talk about this? And you can hear what other people in the industry think. And so it's been pretty exciting. They have it all, the GOOSE working, they're working on the MMS and getting an HMI screen going. So it's been pretty exciting. And 2 of them are coming back as interns for us, and 2 other of the team members, I think, took jobs at ComEd. So I feel like I'm really training they're going to walk in here knowing more than some of our own engineers. So that's pretty exciting.
That's great to hear. It's a great case study, no doubt. I'm sure they value and appreciate the attention you've been giving them. So at this point, John, you've done a phenomenal job, and we've been throwing a lot of questions at you. But now we have what's called the lightning round, which gives us an opportunity to learn more about you, the person, rather than you, the professional. So we've got a series of questions that we'll throw at you. You should keep your response to 1 word or phrase. Are you ready?
I am ready.
All right. First question. Guilty pleasure food.
Vanilla ice cream.
Do you have any hidden talents?
Writing songs.
Favorite way to spend your downtime?
Running or working out.
Who do you look up to?
Blackburn or Dr. Schweitzer.
What are you most passionate about?
Learning.
That was fantastic. Nice navigating the lightning round. And we're going to give you the last word. So what is your takeaway message to our audience from today's conversation? My takeaway message would be, I think it's worth everybody who's doing substations and should be thinking about a DSS to some extent. And when you do, and you're going to approach the technology and try and implement it, make sure you engage all your internal stakeholders. Make sure you do some trip visits, go find other utilities that are doing this. We're not the only one. So go out there and take a look at that. Take a look at, how do you want to implement it, and when you get done, how do you implement your training? That's the other big thing is, how do you keep the momentum going? Because if you just do it once and then don't talk about it again, it becomes a thing that 3 people know about and everybody else is afraid of. So you got to make sure that that's not the condition you want these substations. My goal on our substations is to make those the substations people want to go to first, because they don't want to go to the old wired substation. So that's what I'm targeting. Understood. That's a great insight and certainly a great perspective. Another example of the challenges and trends in modernizing our aging infrastructure. So, great going, and it's great to see it coming out of ComEd and the benefits to the Chicago community. No doubt we'll get a lot of activity and questions on the platform with this conversation. So, John, certainly stay in touch with us and keep an eye out for questions and comments that the community will be sharing on the platform itself. So once again, John Bettler, Power and Protection Engineer at ComEd. Thanks for joining us today. Thank you. You can always reach John through the platform. We welcome your questions and comments. And we also want to give a shout out of thanks to the podcast sponsors that made today's episode possible. Thanks to West Monroe. West Monroe works with the nation's largest electric, gas, and water utilities in their telecommunication, grid modernization, and digital and workforce transformations. West Monroe brings a multidisciplinary team that blends utility, operations, and technology expertise to address modernizing aging infrastructure, advisory on transportation electrification, ADMS deployments, data and analytics, and cybersecurity. Once again, I'm your host, Jason Price. Plug in and stay fully charged in the discussion by hopping into the community at energycentral.com, and we'll see you next time at the Energy Central Power Perspectives podcast.